Lesson 12-6, Rational Expressions with Unlike Denominators. And in this lesson, you learn to add and subtract rational expressions with unlike denominators and to make an organized list of possibilities to solve problems. Now, why is it important? Because you can use rational expressions to solve problems involving astronomy and automobile maintenance. So let's take a look at this example in astronomy. Mars, Jupiter, and Saturn revolve around the Sun approximately every 2 years, 12 years, and 30 years, respectively. Okay? The planets are said to be in conjunction or alignment when they appear close to one another in the Earth's night sky. So the last time this happened was in 1982. And when will it happen again? So Mars will go through 6 revolutions for each one of Jupiter's. Mars will go through 15 revolutions for each one of Saturn's. The times the planets align is related to the common multiples of 2, 12, and 30. Okay? In fact, okay, the least number of years that will pass until the next alignment is what we call their least common multiple of these numbers, or their LCM. The least common multiple is the least number that is a common multiple of 2 or more numbers. So we studied LCM in 6th grade, we studied in 7th grade, and then we'll go back to it again today. And there are two methods, okay, you can use to find the least common multiple. Method number 1, we make an organized list. You can often solve problems by listing the possibilities in an organized way. Use a systematic approach so you don't omit any important items. So when you talk about multiples of 2, that definition of a multiple, it's a number is a multiple of a number, okay, anytime it is multiplied by any whole number. Okay, so for example, multiples of 2 will include 0 because 2 times 0 is 0, so that is a whole number multiplied by 2. 2 times 1 is 2, whole number multiplied by 2, so anything multiplied with 2 will make it a multiple of 2. So all the way down, 2 times 30 is a multiple of 60 is a multiple of 2. Multiples of 12, any whole number multiplied by 12 will be its multiple, and one of them, of course, will be 0. 12 times 1, 12 times 2, 12 times 5, which is 60. And multiples of 30, same thing. Okay, 30 times 0, 30 times 1, 30 times 2, which is 60. Okay, and if you notice, compare the multiples in the table. Other than 0, we want when you talk about the LCM is non-zero, so that means it cannot be 0. So other than 0, the least number that is common to all three lists of multiples is 60. So the least common multiple of 2, 12, and 30 is 60. Okay, so that is method number 1. Let's take a look at method number 2. Okay. Oh, I think it's going to be in the next page. Yep, it is. So method number 2 is by using prime factorization. Okay. So we want to find the prime factorization of each number. And the prime factorization of 2 is 2. Prime factorization of 12 is 2 times 2 times 3. And 30 is 2 times 3 times 5. We all know that. And then what we do next is you use each prime factor. You use each prime factor the greatest number of times it appears in any of the factorizations. Okay, so 2 appears twice as a factor of 12. All the other factors appear once. So the LCM of 2, 12, and 30 is 2 times 2 times 3 times 5, or 60. Okay, we can also, let me just go through this, and then I'll show you another method of doing that, which we've been doing in 6th grade and 7th grade. Okay. Using either method, LCM is 60. This means that the planets will be in alignment approximately 60 years after 1982, or about 20,042. Okay. And you can use the same methods to find LCM of 2 or more polynomials, and that's going to be in example 1. But before we do that, remember how we did this. If you want to find the LCM of those three numbers and list them, 2, 12, and 30, and write down their prime factors. This is 2, this is 2 times 2 times 3, and this is 2 times 3 times 5. And circle the common multiples, or circle common factors. 2 is common to all three. Okay, these three are common to 12 and 30, but not to 2. But since we're looking for the LCM, we circle them as well. And then we simply bring the numbers down once, 2 and 3. And the numbers we did not circle, which are 2 and 5, we need to bring down as well. It's 2 and then 5. And we multiply all of them. And that's how you get the number 60. So the LCM is 60. Okay? Let's take a look at example number 1 and see how this works. You want to find the LCM of 15a squared b squared and 24a squared b. Okay? So, list the factors. Okay? List the multiples of each coefficient and each variable expression. And here we go, 15. These are the multiples of 15. These are the multiples of 24. Okay, and if you notice, 120 is your least common multiple there. Okay, these are multiples of a squared, multiples of b squared, and multiples of b. Okay, so you have a squared. Okay, the only variable there, so you take a squared, and then you have b squared. Okay, b squared and b, you want to find the LCM, which is, in this case, b squared. Right here, everything in blue, we bring it down. So now we have the LCM, which is 120 a squared and b squared. Okay? Or another way of doing it is that you now have 120, okay, and then you do a times a, and this is b times b, and this is simply b. So what you do is simply circle your common multiples. That's a b, circle that, and you don't circle any of these things, so that you bring both of them down, which becomes a squared, and bring down that b, and bring down this other b. So bring down the two a's, bring down one b, and bring down this b. So it's, you notice, it's still a squared and b squared. Okay? Now let's take it one step further. We want to find the LCM of two polynomials. Okay? We want to find the LCM of x squared minus x minus 6 and x squared plus 2x minus 4. So going back to our factoring, okay, we have x squared minus x minus 6. Using the x method would be x minus 3 times x plus 2. And x squared plus 2x minus 15 using the x method would be x plus 5 times x minus 3. Just like our LCMs, okay, we circle our common factors. Okay, so in this case, our common factor would be x minus 3. So we circle x minus 3, and then we bring it down once. Okay, we bring it down once, and then we circle x plus 5, which does not have a common factor, and bring that down once, and we circle x plus 2, does not have a common factor, and bring both of those down once. So you end up with the LCM as x minus 3, which is the one that we circled in green, x plus 2, which is the one we circled in red, and x plus 5, the other one that we circled in red. Okay, so that's how you find the LCM of two polynomials by using factoring. Okay, let's take a look at before we take a look at example number 3, let's learn this concept. Oops, where is example number 3? I think it's the bottom. Yes, it is. to add or subtract fractions with unlike denominators, okay, first rename the fractions so that the denominators are alike. Any common denominator could be used. However, the computation usually is easier if you use the LCD, or the least common denominator. Recall that the least common denominator is the LCM of the denominators. So you usually use the following steps to add or subtract rational expressions with unlike denominators. The first step is find the LCD. The second step is to change each rational expression into an equivalent expression with the LCD as the denominator. And step number three, add or subtract the rational expressions with like denominators. This is from the last lesson. Number four, simplify if necessary. I'm sorry. So basically, this is what we're trying to do. Let's say you want to add 3 over 5 plus, let's say, 4 over, let's say 4 over 20. Okay, let's do 4 over 15. There you go. Okay, so remember what we used to do here. So we get 3 over 5 plus 4 over 15, and we find the LCD of 5 and 15, which is 15. And then we simply bring the 4 again on the right side. What did we multiply 5 to get to 15? We multiply this by 3. Therefore, we need to multiply this by 3 too. So this becomes 9 over 15. Okay? So if we add those two, 9 plus 4, that'll give us 13 over 15. And that's how we add fractions with unlike denominators. It is nothing different in example 3. Just like adding fractions, adding rational expressions is basically very similar. Let's take a look at example 3. We want to find 7 over 3m plus 5 over 6m squared. Okay? We want to find the factors of 3m, which is 3 times m. We want to find the factors of 6m squared, which is 2 times 3 times m times m. Okay? And then the LCM would be, okay, you have a common factor of 3. Common factor of 3. Those two we will bring down once. And the ones which do not have common factors, we will bring down as well, which are 2 and m. So we're bringing down 2, 3, m, and m. Okay? Okay, sorry about that. I just got a text message from my son. Okay, moving on. So we have 3m. We're bringing down the 2, the 3, and the 2m. So the LCM would be 2 times 3 times m, or 6m squared. Okay? So 6m squared will be our LCM. Okay? Now, if I use the method like what we do with our regular fractions, I can do this 7 over 3m plus 5 over 6m squared, and do exactly as I did there. LCM would be 6m squared, and then ask ourselves, what did I multiply 6m squared to become 6m squared? That's 1. So I simply copy the 5. What did I multiply 3m to get to 6m squared? That would be 2. And therefore I would need to multiply 7 by 2 as well, so this becomes 14. Now that I have common denominators of 6m squared, I simply add my numerators, and that becomes now 19 over 6m squared. Okay? And if you look at what the book did, that's exactly what they did. You have 7m plus 7 over 3m plus 5 over 6m. Okay, and the LCM is 6m squared, and that's the reason why you multiplied 7 by 2m. Okay, oops, I forgot. Should be multiplied by 2m. Sorry about that. Because this becomes 14m. And this becomes, this now becomes, let me recorrect my answer here. So instead of 14, this is of 19m, this now becomes 14m plus 5 all over 6m squared. Okay, so let's see if we're correct on this. Okay, so from there we simplify. That's 14m plus 14m all over 6m squared plus 5 all over 6m squared. That will give you 14m plus 5 all over 6m squared. Same answer that we got the first time around. Okay? The secret word for this particular lesson would be panthers. Secret word would be panthers. And let's take a look at example number 4 and finish this up. You have example, nope, not 3. Want to example 4. Where's example 4? Oops, we will finish with example 3. Is example 4 on the bottom? Nope, it's after that, right there. So to combine rational expressions whose denominators are polynomials, follow the same procedure as you use to combine expressions whose denominators are monomials. So this is now where your head will spin if you don't pay attention closely. So find each sum or difference. So letter A, you want to find the sum of s all over s plus 3 plus 3 all over s minus 4. Okay, now contrary to popular belief, the LCM is not s plus 3 minus 4 simply because there are two s's. Remember, you're looking for least common, okay, least common multiple. Therefore, in this case, your least common multiple would be s plus 3 and s minus 4. So you have s plus 3 and you want to find the factors of s plus 3 and you want to find the factors of s minus 4. Okay, the factors of s plus 3 is nothing more than s plus 3. And the factors of s minus 4 would be s minus 4. The factors are not s and 3 and not s and negative 4. Okay, it's s plus 3 and s plus 4. So following our rule and trying to find LCMs, okay, since there is no common factor, we do not, I repeat, you do not circle the s's and then bring that down once and bring down the 3 and the 4 also. That is not allowed. So this is a factor, that is a factor, therefore the LCM would be s plus 3 times s minus 4. Oop, what happened there? Okay, so s plus 3 times s minus 4. What happened? There we go, there we go. There we go. Okay, so what happened? Let's redo that again. So our LCM, so you have s plus 3 and s minus 4. Okay, this becomes a factor of s plus 3 and this is s minus 4. So our LCM, why did I write it on invisible ink? It's going to go away all of it. Our LCM is nothing more than s plus 3 and s plus 4. Okay? So, since the denominators are s plus 3 and s minus 4, there are no common factors like what we talked about. So, the LCD is s plus 3 times s minus 4. Okay? And if that's our LCD, we can rewrite this. Okay? Okay? What we did, we multiply s plus 3 to get to our LCM, we multiplied it by s plus 4, and therefore we need to multiply our numerator by s minus 4 as well. What did we multiply s minus 4 to get to our LCM? We multiplied it by s plus 3, and therefore we need to multiply the numerator by s plus 3 as well. Remember, we're multiplying both of them by 1, so it doesn't really change our rational expression because we're simply multiplying by 1. Okay, if you want to write this vertically, this is how you write this. You now have s over s plus 3 plus 3 over s minus 4, and the LCM is s plus 3 times s minus 4. LCM is s plus 3 times s minus 4. Okay, and just like what they did in the problem, we need to multiply this by s minus 4 and s minus 4. Okay, and this one, s plus 3 over s plus 3. There you go. Okay, so if you do that, okay, you end up with, in this case now, make it thinner so easier for me to write on. So this now becomes s squared minus 4s. And this now becomes 3s plus 9. Okay? And then we rewrite the entire thing with a common denominator, okay, of s plus 3 times s minus 4. Then we copy the numerator, add them all up. So you now have s squared minus 4s plus 3s plus 9. And if we simplify that, okay, you now have s squared minus s plus 9 all over s plus 3 times s minus 4. Okay, and if you notice, you cannot factor s squared minus s plus 9, okay, because that's a prime polynomial, and this is our simplest form. Okay, or you can multiply s plus 3 times s minus 4 using the FOIL method. So you now have s squared minus s plus 9 all over s squared minus s minus 12. So both answers will work. This will work and this will work as well. And let's follow along. Okay, this one is done vertically. This one was done horizontally. And from there, we end up with the same thing, s times s minus 4 and 3 times s plus 3. Okay, put them all in the common denominator. Or first distribute the s and distribute the 3. Put them all on common denominator. You end up with s squared minus s, okay, plus 9. Okay. Or if you want to do the FOIL method, you can do s squared minus s plus 9 all over s squared minus s minus 12. Okay? And let's take a look at letter B. Now this will involve factoring, so pay attention. You have n minus 4, okay, all over 2 times n, or quantity 2 minus n squared, minus n minus 5 all over n squared plus n minus 6. So you want to find the LCM, okay? And take note of this because this is very important and something that you will encounter when you have 2 minus n squared and n minus 2 squared. Are they equal to each other? Let's find out. So 2 minus n squared is the same as 4 or 2 minus n. Sorry, let me make my lines thinner so it's going to save space. Okay, thin line, there we go. Oops, thin line, there we go. Okay, so 2 minus n is the same as 2 minus n times 2 minus n, right? And 2 minus n times 2 minus n, remember this is a perfect square trinomial. So this is 4 because that's 2 squared. And since that's a minus, minus 2 times 2 times n plus n squared, which is the same as 4 minus 4n plus n squared, or n squared minus 4n plus 4. Okay, for 2 minus n squared. And if you have 2 minus n squared as well, if you notice, if you follow this as a perfect square trinomial, this is the same as n squared minus 2 times 2 times n plus 2 squared, or 4. If you notice, they're one and the same. So 2 minus n squared is the same as n minus 2 squared. Okay, so now that's cleared up. Okay, let's copy the problem and let's find the difference of the two. So we have n minus 4 all over 2 minus n squared minus n minus 5 all over n squared plus n minus 6. Okay, if we factor n squared plus n minus 6, this is what we're going to have, n minus 2 times n plus 3. Okay, and then we know that 2 minus n squared is the same as n minus 2 squared. So what happens is that we simply substitute 2 minus n squared to become n minus 2 squared, or expanding it is the same as n minus 2 times n minus 2. Okay, now the trick is to find the LCM. Okay, and to find the LCM of n squared times n squared, I'm going to put it here. Okay, so let me copy that. Okay, n squared, to find the LCM of n squared, n minus 2, sorry, times n minus 2, and n minus 2 times n plus 3. Remember what we do? We circle the common factors, circle these two, and we bring it down once, which is n minus 2, right? And these two are not common, so we bring both of them down once. We bring n minus 2 down once, and we bring n plus 3 down one more time. So this now becomes our LCM. So the LCM of this denominator would be n minus 2 times n minus 2 times n plus 3. Okay? So using that LCM, okay, we rename each fraction using our LCM, or in this case now becomes our LCD because that's our least common denominator. Okay, and since our LCD is n squared minus n squared plus 3n, what did we multiply n minus 2 times n minus 2 to get to our denominator? That would simply be n plus 3 all over n plus 3. And what did we multiply n minus 2 times n plus 3 to get to our denominator? We multiply it by n over 2 times n over 2. And we simplify that, n minus 4 times n plus 3 using the FOIL method, okay, which will becomes n squared plus 3n minus 4n minus 12, minus, okay, and put it in parentheses. Remember that subtraction always indicates that you need to put that into parentheses. Okay, again using the FOIL method, n squared minus 2n minus 5n plus 10. Okay, simplify our numerators. That becomes n squared minus n minus 12 minus n squared. Now look closely. Okay, the n minus 1, or the negative 1, has been distributed. So that's the reason why it becomes n squared plus 7n minus 10. Because remember, if I simplify this, this is n squared minus 7n plus 10. And if I distribute the negative sign, this becomes negative n squared plus 7n minus 10. Okay? And we simply add our like terms. Okay? Combine our like terms. Okay? N squared and n squared go away. That becomes 0. Negative n plus 7n becomes 6n. And negative 12 minus 10 becomes 22. And this is now the difference of those two rational expressions using LCDs. Okay? So rewind the video if you did not fully understand letter B. Thank you for watching.